Okay, we're looking at the the first year core textbook, mixed exercise 11, which is on vectors. So I've got a boat that's drifting in the sea, and we're just modelling it as a particle, so that means we don't need to take its size into account in this situation. Straight line at constant speed, and I'm given its position at 9 o'clock, so we'll take that as our starting time, and then I'm given its position 40 minutes later, and I'm asked the bearing on which it's drifting. Okay, so let's get a sketch of this. Okay, so it starts, well, let's just draw it on an X and Y axes to start with. So it's starting at a position vector of -2, -4. So that's -2 in the X direction, that's my I vector, and -4 in the Y direction. Let's get that out of the way. Okay, so if I were to draw it on a coordinate axis, it would look like that. And then it moves to 4 -6, so that's going to be, that's going to be, needs to be lowered, isn't it, because it's down at -6. Okay, so that's if I was just sketching it as coordinates, and they want to know, so obviously that's how it's traveling, so that's where it started and that's where it finished, or that's when it was at 9:40. So obviously we always measured bearings from due north, so that's going to be the bearing it was traveling on. Okay, so what's the best way of getting that? Well, I think if I get the resultant vector, which I could do just from completing this sketch. So basically, if I just think about how it's travelled, so it's travelled from X is -2 to X is 4. Let's get a colour that's slightly easier to see than that. So it's travelled from -2 to 4, so it's travelled 6 to the right, and it's travelled, let's get that out of the way, it's travelled from Y is -4 down to Y is -6, so it's travelled 2 down. So if I just look at that right angle triangle, I can get that angle there, and then if I take that away from 180, I'll have the bearing. There's other variations on how you might have got there for this. Okay, so so let's call that one alpha. So tan alpha is opposite over adjacent, and I'm just looking at the magnitudes, so I don't need to worry about the -2. So alpha is arctan of 6/2. So 71.6 degrees. So that's that angle there. So the bearing obviously is measured from due north. So that angle there. So that is just going to be 180 minus 71.6. So 108.4. Well, that's to 4 significant figures. But anyway, as a bearing, you'd always just give it as 3 figures. Okay, and then find the speed of S. Okay, so because we want the speed rather than the velocity, I can just do it as distance over time. So the distance it's travelled is going to be that distance there. So the distance, and again, if I just sketch out again, but I am just thinking about right angle triangles. So I've already just worked out here that it travelled 6 to the right and 2 down. So that's 6. And again, I'm not bothered about the fact it's -2. So I'm just looking at the magnitudes. So the distance it's travelled is going to be the hypotenuse of that triangle. You could get the velocity as a vector and then do it from that as well. That would work. So the distance is going to be 2 squared plus 6 squared. So root 40, and that I'm going to just leave that as an unsimplified surd there because that's just part of my working. So then I'm just going to use the speed is distance over time. So root 40, and then I want this, I don't know if it specifies how to give the speed. No, so it doesn't, but I think we're in kilometres or, yeah, so we're in kilometres. So kilometres per hour, I think, would be the most sensible thing. So when I'm thinking about time, it took 40 minutes from 9 o'clock to 9:40. So I'm going to change that into hours before I, now rather than after I found the speed. So 40 over 60 is, see, 2/3 of an hour. Okay, so when I do my speed, I'm going to do 40 divided by 2/3. I just find that easier than finding it in kilometres per minute and then converting. So root, be careful with typing that into my calculator. So root 40 and then divided by 2/3. So for me, that's coming out. It's coming out as 3 root 10. I'm going to just give it to 3 significant figures. So that's coming out for me as 9.49 kilometres per hour. And it is important you put the units, but particularly in a question like this, because of course I could have given it in kilometres per minute. It's not really a standard unit we'd use, but it should work. So 9.49 and 108 degrees, lovely.